The Big Bang Theory has long been recognized as the foremost explanation for the origin of our universe, enduring as a framework through which astrophysicists interpret the complex phenomena observed in the cosmos today. Over time, this theory has been refined and bolstered by an ever-growing body of evidence, solidifying its position as a cornerstone of modern cosmology. It offers a coherent narrative of how the universe began approximately 13.7 billion years ago, starting from an incredibly hot and dense point that rapidly expanded. According to this theory, the universe was born in a colossal explosion that set the cosmos in motion, allowing us to trace the origins of galaxies, stars, and even the building blocks of life itself. However, the mystery deepens when we attempt to comprehend what, if anything, existed before the Big Bang. The events preceding that moment remain shrouded in mystery and are currently beyond human understanding. In recent years, however, this narrative has faced challenges from new findings by the James Webb Space Telescope, JWST, sparking controversy and even panic among some cosmologists. These photographs suggest discrepancies with the Big Bang Theory, prompting scientists to reassess their understanding of the universe's origins. As we examine the evidence presented by the JWST, we find ourselves on the cusp of potentially revolutionary discoveries, questioning long-held beliefs and opening the door to new possibilities in astrophysics. The excitement surrounding the James Webb Space Telescope is palpable within the scientific community. This next-generation telescope represents a monumental leap forward in our ability to observe the universe, particularly with its advanced capabilities in capturing infrared wavelengths, promising to reveal aspects of the cosmos previously hidden from view. Scientists around the world have eagerly awaited their chance to use this powerful instrument since it became operational. The JWST is more than just another telescope, it is a groundbreaking tool with the potential to answer some of the most profound questions about the universe. Initially, the expectation was that this telescope would build upon the successes of its predecessor, the Hubble Space Telescope, providing even clearer and more detailed images of distant galaxies, star systems, and perhaps even the earliest moments of the universe's existence. What came as a surprise, however, were the unexpected discoveries that challenged the Big Bang Theory itself. Within just 2 months of its operation, the JWST captured images that defied conventional understanding, suggesting that the universe might not have begun with the Big Bang as previously thought. This revelation has sent shockwaves through the scientific community, prompting a re-evaluation of theories that have been accepted for decades. For many years, the Big Bang Theory has been deeply embedded in the collective imagination of humanity. It has been taught in schools, referenced in popular culture, and widely accepted as the definitive explanation for how the universe began. According to this theory, everything we see today, from the smallest particles to the largest galaxies, originated from a single point in space and time. Georges Lemaître, a Belgian priest and astronomer, first proposed this idea in 1927. Lemaître's theory was revolutionary, suggesting that the universe was once compacted into a primeval atom that exploded, causing the expansion that continues to this day. His work laid the foundation for what would become the Big Bang Theory, a model further supported by the work of Edwin Hubble. Hubble's observations of distant galaxies moving away from us provided the empirical evidence needed to validate Lemaître's theory. His discovery that the universe is still expanding was a pivotal moment in the history of astronomy, solidifying the Big Bang Theory as the leading explanation for the origin of the cosmos. The theory posits that the universe started from an extremely hot and dense state and has been cooling and expanding ever since, leading to the formation of stars, galaxies, and all other cosmic structures. The narrative of the Big Bang Theory describes a universe that began in an incredibly dense and hot state, filled with a chaotic mixture of subatomic particles, light, and energy. Over time, as the universe expanded, it began to cool, allowing particles to combine and form atoms. These atoms eventually clumped together under the force of gravity, forming the first stars and galaxies. This process of cosmic evolution continued over billions of years, leading to the complex and diverse universe we observe today. The early stars played a crucial role in producing heavier elements through nuclear fusion, which later became the building blocks for planets, asteroids, and other celestial objects. Galaxies collided and merged, giving rise to even larger galaxies and triggering the formation of new stars. Black holes, comets, and other fascinating cosmic phenomena emerged as the universe continued to evolve. This grand narrative has been supported by a wealth of observational evidence, making the Big Bang Theory the most widely accepted explanation for the origins of the universe. However, the recent findings from the James Webb Space Telescope have raised significant doubts about this narrative. What if the Big Bang never happened? This question challenges the very foundations of modern astronomy and forces scientists to reconsider everything they thought they knew about the universe's beginnings. The recent images captured by the James Webb Space Telescope have thrown the scientific community into a state of uncertainty. These images appear to contradict the Big Bang theory by showing galaxies that seem to have formed before the time the Big Bang is supposed to have occurred. According to the Big Bang theory, the most distant galaxies should appear as they did billions of years ago when the universe was still in its infancy. These galaxies should be relatively small and not yet fully evolved. However, the images from the JWST suggest otherwise. Some of the galaxies observed are large and bright, indicating that they may have formed much earlier than the Big Bang theory would allow. If these findings are confirmed, they would radically alter our understanding of the universe's history. The idea that the universe began with a Big Bang has been a cornerstone of cosmology, but these new observations suggest that our current models may be incomplete or even incorrect. This has led to a great deal of anxiety among scientists who have long supported the Big Bang theory. Cosmologist Richard Ellis, for example, has expressed concern over the implications of these findings, noting that they could challenge the very foundations of cosmology. One of the most intriguing aspects of the James Webb Space Telescope's findings is the discovery of an unusually large number of smooth, compact, and ancient galaxies. These galaxies seem to defy the expectations set by the Big Bang theory. If the universe is indeed expanding as the Big Bang theory suggests, then we would expect to see galaxies appearing smaller and fainter as we look further back in time. However, the JWST images show something quite different. The galaxies appear to be larger and more massive than expected, raising questions about our understanding of the universe's expansion. This observation could indicate that we are witnessing an optical illusion caused by the expansion of the universe, or it could suggest something even more profound, that our current theories about the universe's expansion are fundamentally flawed. The apparent discrepancy in the size of distant galaxies observed by the JWST compared to those observed by the Hubble Space Telescope has sparked intense debate among scientists. If the universe is not expanding in the way we currently believe, then the galaxies observed by the JWST should be the same size as those closer to us, and the redshift we observe would need to be reinterpreted. This challenges the Big Bang hypothesis and opens up new avenues of research into the true nature of the cosmos. The discovery of smaller-than-expected galaxies by the James Webb Space Telescope has profound implications for our understanding of the universe. If distant galaxies are indeed smaller than we thought, it could mean that our current models of cosmic evolution are incomplete or incorrect. This revelation has sparked a flurry of speculation and debate within the scientific community. Some theorists suggest that the discrepancy in galaxy size could point to variations in the fundamental laws of physics when applied on a cosmic scale. This would imply that the rules governing the universe might change depending on the distance from the observer or the conditions of the environment. Others propose that there could be unknown factors or phenomena influencing the appearance of